1 second, sir, because my computer have little problem. Yeah, it is visible, sir, now, the PPT. But your voice is not clear, sir. Hello. Okay, but it is clear. Okay. Yeah. Yeah. Shall I start or we have to wait for the participants? Strength, strength for CSE. Sir, your voice is not clear. Okay, I got one chat message. Yeah, my my voice also not clear. Students are telling. Yeah. Yeah. I will give you important questions. Don't worry. Okay, my voice is clear. Yeah. Okay. Yes. Yes. I have to record where it is. Um, I I'm not getting record option. Yeah, I got, sir. I got, sir. I got, sir. Is it clear, sir? Yeah. Okay, shall I start, sir? Participants are 234. Sandeep, sir. Good morning, everyone. Yeah, I got message. Okay. Good morning. So, in our M2 subject, today we are going to discussing 4th unit and tomorrow 5th unit. Then, Thurs Wednesday and Thursday it is first and second units. Then lastly, again touching of the 5th unit, because multiple integrals are very lengthy. If it is possible to complete, will complete. Otherwise, you have to study. And this today we are discussing 4th unit. Just brush up all the definitions, and then I'll give the important questions also. We'll discuss the old question papers also. Okay. Today's agenda is this is third unit. Just will discuss. Third unit will teach you Balakrishna sir. Fourth and fifth units, and I will teach. Okay. So first one, the definition we are going vector differentiation. Fourth unit is the vector differentiation. First we are discussing vector. It is, let S be a set of real numbers corresponding to each scalar. Some t belongs to capital S. Let there will be associated a unique vector f bar, then f bar is said to be vector function. So some unique vector, it is defined to the associated to that function, and it is denoting as f bar is equals to f bar of t. Symbolically it is representing I bar, j bar, k bar, three mutually perpendicular vectors, unit vectors. Then f bar is symbolically representing as f1 of t I bar plus f2 of t j bar plus f3 of t k bar. This is definition of vector. Then how to differentiate vector. So you know differentiation formula. Similarly here also. Yes. What a problem. 1 second. Yeah, one more time you want to explain? Okay, I will explain. Just we are discussing what is vector. There is no definition. Just what is vector. X is a set of real numbers, and each scalar in that real numbers, they're associated a vector. Each scalar, they are associating a unique vector. So that unique vector is representing as f bar, and f bar is equals to f bar of t. And this f bar of t is denoting as I bar, j bar, k bar, we know that is three mutually perpendicular unit vectors in the three-dimensional space. So symbolical representation of this unit vector is f1 of t I bar plus f2 of t j bar plus f3 of t k bar. You know representation of vector. Just we are discussing representing of vector. Here f1, f2, f3 are real valued functions. That means real numbers. Example, if you are considering any vector v bar which is equals to 2 I bar plus 3 j bar plus 4 k bar. So 2 comma 3 comma 4 are real numbers. So just representing of a vector here. But why we are representing here, how to represent the vector and this unit, we are totally discussing you vector differentiation. So what are the differentiation terminology we are using, different method here we have, so that we are using in this chapter. So next, derivative, how to differentiate vector. Here we are taking f bar is a vector and L is an interval here, and in that A belongs to in that interval. Symbolical representation as usual of the differentiation formula, limit t tends to A, f bar of t minus f bar of A by t minus A. This is differentiation formula. It is symbolically represent as f bar dash of A or f bar of df bar by dt at the point t is equals to A. We say that it is differentiable at t is equals to A if f bar of dash of A is exist. It is clear, this is derivative. You know the derivative formula. Derivative is as usual. We know that if any in real valued functions, if it is going for the derivative, we know that f of x minus f of A by x minus A, where x tends to A, limit same definition we are using here, but it is in the vector function. That is limit t tends to A, f bar of t minus f bar of A by t minus A. This is derivative. So after that we have two more important definitions are there. These definitions are useful for your short answers also. One is scalar point function and vector point function. So for scalar point function, we considering the region in the three-dimensional space, and a point we are assuming p of x comma y comma z. Suppose we associated a unique real number. Here unique real number we are treating as a scalar, that we are taking as a phi. This phi is called scalar point function. This is in three-dimensional. We are assuming a point p of x comma y comma z. Suppose we are associating a unique real number or scalar which we are taking as phi. This phi of x comma y comma z is called scalar point function. Same way, if we are assuming in three-dimensional p of x comma y comma z and we are associating a unique vector, that is called vector point function. Otherwise, if we are associating a scalar function, then it is called scalar point function. So these two definitions are very important for the short answers. So what is scalar point function and what is vector point function? If you have, we have some examples also here. Suppose if it is taking a heated solid, one point, if we are considering in p of x comma y comma z, there will be a temperature. That temperature is scalar, so that is called it is scalar point function. And we are assuming that a particle is moving in a space. We are tracing its position p of x comma y comma z, and at that position there particle have some speed that we are taking as v. This v is called scalar vector point function, not scalar point function. This is vector point function. Okay, these are the examples here. Then after that we have one more definition, that is vector differential operator. In now onwards we have this operator is very useful because other definitions are all depending on this vector differential operator. Okay, This vector differential operator is denoted by del, and it is defined as I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou x. This is a one you have to remember for differential operator. Vector differential operator, this is called. It is denoted by del, which is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou x. This is the one you have to remember. This is vector differential operator. Using of this vector differential operator only, we have depending on different definitions. We have next definition. This is including with vector differential operator. First definition is gradient of a scalar point function. So scalar point function having a gradient having only only scalar point functions. Already we know what is scalar point function. Now we are applying gradient of a scalar point function. What is scalar point function? We in a three-dimensional space, p of x comma y comma z, one is any one of the point. At that point, for that point, we are associating a scalar. We are assuming that as phi. Then phi of x comma y comma z is called scalar point function. So that is the definition of scalar point function. Phi of x comma y comma z is scalar point function. Then how to calculate gradient of that scalar point? So for phi of x comma y comma z be a scalar point function. Now we are discussing that gradient of a scalar point function. Okay. Let phi of x comma y comma z be a scalar point function of a position defined in some region of space. So the function, what you know, what is del? Del is what happened, ma'am? What is gradient of a scalar point function? What does it signify, ma'am? Okay. After telling the definition, I will discuss the physical interpretation of the gradient also. Don't worry, just we discuss now. Okay. After completion of the definition, sure I will explain. Again, what's the problem? Okay, it's okay. 49, rule number, okay, ma. Yeah, here we are considering scalar point function. Now you have idea of the scalar point function. Now for that, position defined in some region of space, then the I bar dou phi by dou x, the vector function I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z is known as the gradient of phi, and it is symbolically represented as grad phi or del phi. Okay, here del operator we are using. If it is a del operator, we are just using del phi, it is gradient. Del dot phi is divergent. Del cross phi is curl. So there is a three definitions depending on this vector differential operator del. So in the question, first you have observed what's the relation is given with the del. It is directly del phi is given, or del dot is given, or del cross is given. That is important. Depending on that, we have to solve the questions. Okay. This is a gradient. Gradient is I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. So this grad phi or del phi. This is a formula. So now coming to the physical interpretation, what will work in the gradient? For that, just roughly I'm explaining. If we explain the terminology in the physical representation, it is del. For your understanding, I'm giving one of the example. So take 2 buckets of water. If you the movement is going on here, there is no just it is rotating there in that only. But if we make a hole to any one of the bucket in the two buckets, some water is coming out. That flow, outward flow or expansion of that fluid from their point at any time is measured as divergence. Is it clear? This is a physical interpretation of the divergence. I will share you if you I thought you have all these PPTs, but anyway, if you want, I will again send these PPTs. Don't worry. So this is physical. I'm one more time explaining. Imagine two buckets of water we can consider. Measure the rate per unit of volume, which is flow. We make one of the hole to one of the box or one of the bucket. So fluid is coming out. The divergence of F bar measures the outward flow or expansion of the fluid from their point at any time. The flow, what is going on? Sure, ma. I will send PPTs. Don't worry. I'll give my WhatsApp number. Please send your email CRs. I'll forward it to this PPTs. Okay. This what is the flow which is coming out, outward flow. This is called fluid. So at the same time, you maybe understand for the what is the difference between divergence and gradient and curl. We have same example we consider there. Then we'll discuss now. Then we'll go for the next. Then properties of gradient. It is clear grad of f plus or minus g is equals to gradient of f plus or minus gradient of g. Then necessary and sufficient condition for a scalar point function to be constant is that del f is equals to 0 bar grad fg is equals to f grad g plus g grad f. If c is a constant, then grad of cf is equals to c into grad f. Then the next property, if it is grad in the u by v method, that is also same as differentiation of u by v, g into grad f minus f into grad g by g square. Here g is not equals to 0. These some of the properties you have to remember. And the damn sure question of this unit is directional derivatives. This is a formula you have to remember, that is E bar cross del bar, where E is unit vector in that direction. This is directional derivative. In under this directional derivative, we have two more questions also. One is greatest value and another one is angle between the surfaces. So these three this greatest value is not a direct question, that means it is a short answer, but angle between two surfaces and the directional derivatives are very very important questions. And in this mostly damn sure question of this directional derivatives, in the textbook we have more solved examples are also there. Please go through the textbook and solve all the directional derivative problems. This is the most problems we have under this in the textbook also. Okay, so what is directional derivative? Now we discuss. So directional derivative are also having a scalar point function phi at a point p of x comma y. So in that point direction, we are taking a unit vector e bar, which is equals to e bar dot del phi. Already we know how to calculate del phi. Del phi is equals to I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. So E bar we need to calculate. E bar is equals to, that is unit vector. Then under this we have two more definitions or two more important points, that are greatest value of a directional derivative. That greatest value of a directional derivative of phi at a point P is equals to modulus of grad phi at the point P. Then angle between, yeah, I will explain problems, ma. I will explain one problem under directional derivative. Okay. Okay. So next, angle between two surfaces n1 and n2, then cos theta is equals to n1 bar into n2 bar by modulus of n1 bar into modulus of n2 bar. Cos theta is equals to n1 bar dot n2 bar by modulus of n1 bar dot modulus of n2 bar. Then we'll discuss one of the problem in directional derivatives. This is also gradient of a function of a function. So how of a function we are taking gradient and also taking its gradient, that is called gradient of a function of a function. Here we are considering u is equals to f of u. U is a function of x comma y comma z. Then we are taking its gradient. It is equals to del v, which is equals to del of f of u, which is equals to del definition is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z into f of u. So f of u is a function of x comma y comma z. First we are taking its derivative as f bar of u, and inside dou I bar dou, one second. Ma'am, can we get PDF for this chapter with clear notes and problems? Actually, I'll try because I'm not sure, because we prepared only PPTs for the last classes, that is in April, which is held in April. I don't have, but I'll try. Okay. This is f bar of u. I bar dou u by dou x plus j bar dou u by dou y plus k bar dou u by dou x. Then f bar of u into del u. This is a gradient of function of a function. So function f is a function and u is also one more function here, because u is depending on three variables x comma y comma z. Then how to calculate gradient of a function of function? This is a formula. Okay. So few more problems are also there. This r bar is a position vector of the point p of x comma y comma z. So we need to del f of r bar we need to calculate, that is equals to f bar of r into r bar by r. So always remember in this chapter, r bar is equals to xi bar plus yj bar plus zk bar. This is r bar position vector, and r square is equals to x square plus y square plus z square. When we differentiating this r square with respect to x comma y comma z, yeah, sure ma, I will send ppts, don't worry. Okay, we have very less time. In this 55 minutes only we need to complete all the topics, and we need to discuss important questions also, please. So this usually r square is equals to x square plus y square plus z square, differentiating partially with respect to x, y, z, we'll get the values as dou by dou x as x by r, dou by dou y as y by r, dou by dou z as z by r. So gradient of a function formula here we are expanding, because f is a function and r is also function of x comma y comma z. So symbolically representing del f bar f of r is equals to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z into f of r. So gradient of a function, first derivative of f symbolically, that is summation form we are writing, that is I bar into dou by dou x of f of r. Now we are applying gradient of a function, so we'll get f of r dou r by dou x, but dou r by dou x value is x by r, and f dash of r, and this writing outside of the summation, then we'll get the only summation is xi bar. But xi bar full form is will get as xi bar plus yj bar plus zk bar. Then it is representing as r bar. So more problems you have in your textbook depending on this r are also important, ma'am. This type of problems also important. Yeah, doubt. Sure, I will explain. Don't worry. This is the question is here we need to calculate r bar is the position vector of a point p of x comma y comma z. We have to prove del f of r. Yeah. Okay. So r bar we are writing, partial differentiations we are calculating and keeping aside. Then what we need to calculate, that is del f of r. So formula of del is, we know that I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z into f of r. This is f is a function ma, r is also function of x comma y comma z. That means gradient of a function we are calculating here. So that shortcut form we are applying, that is in summation form. So instead of writing I bar j bar k bar, we are writing as summation of I bar dou by dou x of f of r. Then this is gradient of a function. So we'll get as f bar dash r, f dash of r dou r by dou x derivative. This f dash of r dou r by dou x. But we calculated dou r by dou x as x by r, substituting. And what are the terms coming out of the summation? Writing, that is f dash of r by r and summation xi. So expanding summation will get as r bar. Xi bar is nothing but expanding yj bar plus zk bar also. So it becomes r bar. This we need to prove. So now coming to the problems of directional derivatives. These are very, very important. Damn sure question compulsory, but in the textbook we have 10 to 12 solid examples under this. Somewhat some slight difference is there. Condition is given differently, but you're able to understand that condition, and what we have to calculate here, you're able to understand, able to identify. Okay. So first, here one of the question we are discussing. Find the directional derivative of f is equals to xy plus yz plus zx in the direction of the vector I bar plus 2j bar plus 2k bar at the point 1 comma 2 comma 0. So according to the directional derivative, here is one of the scalar point function. Suppose phi we are considering, phi is scalar point function at the scalar point function in the direction p of x comma y comma z. So in that direction we need to calculate unit vector. So unit vector we are taking as e bar, then e bar dot del phi gives directional derivative. Directional derivative is applied for scalar point function. Here one of the vector is there, scalar is there. Don't confuse. What we have to consider in vector, scalar. Vector is for finding unit vector, and the scalar we need to calculate grad phi. So given already in the question, that is f bar is given scalar point function. That is what we are considering. F is equals to xy plus yz plus zx. For this we are calculating grad f. Grad f is equals to I bar dou f by dou x plus j bar dou f by dou y plus k bar dou f by dou z. So partial differentiation with respect to x will get as y plus z. You know how to do the partial differentiation. First problem just I'm explaining. So f is partial derivative with respect to x. So with respect to x is x, differentiation of x is 1. So we'll get as y plus, here x terms are not there, 0, yz differentiation, partial differentiation is 0, plus zx partial differentiation becomes z. So that is what we'll get as y plus z I bar plus, with respect to y, we will get as z plus x j bar plus, with respect to z, we'll get as y plus x k bar. This is grad f. Then we need to calculate unit vector. So considering as E bar is a unit vector in the direction of the vector I bar plus 2j bar plus 2k bar at the point 1 comma 2 comma 2, 1 comma 2 comma 0. So look at E bar is that is in that vector by square root of a square plus b square plus c square. So that is the formula here, unit vector. So I bar plus 2j bar plus 2k bar by square root of coefficient of I bar is 1, so 1 square, plus coefficient of j is 2, so plus 2 square, plus coefficient of k bar is 2, so that is equals to 2 squares. After simplification, we'll get as 1 by 3 into I bar plus 2j bar plus 2k bar. This unit vector we calculated and grad f we calculated, but we need to calculate directional derivative. That is the formula is E bar dot del F bar. So first we are calculating E bar dot del F bar. Dot product is I bar into I bar is equals to 1, J bar into J bar is equals to 1, K bar into K bar dot K bar equals to 1. Remaining all zeros. I bar dot J bar also 0. I bar dot K bar is also 0. Similarly, the next two also 0. Only I bar dot I bar equals to 1. So multiplying this, E bar dot del F. E bar is unit vector in the direction what we are given the vector that we calculated, and del F is a scalar point function. We calculated its gradient. So I bar dot y plus z is y plus z. 2j dot z plus x is 2 into z plus x, plus 2k bar dot y plus x k bar equals to 2 into y plus z, y plus x. So 1 by 3 is outside, keeping like that only. But in the direction, the point is also given. We need to calculate at that point this value. So at that point is 1 comma 2 comma 0. So that substituting x equals to 1, y equal to 2, z is equals to 0. After simplifying, we'll get 10 by 3. Directional derivative. Is it clear? We have one more problem also, directional derivative. Shall I speed up because we need to discuss more points. We have only 20 minutes time is there. Okay, so in this first chapter, directional derivatives are very important, damn sure question. You remember, and what is the formula is easy to remember the formulas also. Then okay, ma'am, teach this sum please. I'm not able to understand that statement because fifth unit is very lengthy. We need 2 classes for that. So fourth unit is very short. So that is what I'm running up. But less time is there. That is one. Okay. Then this is one of the problem in directional derivatives. This is also greatest value. Find greatest value of the directional derivative of the function f of x square plus x square y z cube at 2 comma 1 comma minus 1. So roughly I'm just explaining. So grad f we are calculating. You know how to calculate the grad f according to the formula. We are calculating grad f and keeping aside and substituting the point 2 comma 1 comma minus 1. We'll get the grad f value as minus 4 I bar minus 4 j bar plus 12 k bar. So greatest value is value of the directional derivative is gradient, that is modulus of del. So square root of the coefficient of I bar is minus 4 whole square plus the coefficient of j bar is plus minus 4 whole square plus coefficient of k bar is 12 whole square. So simplifying this, the value will get that value is 4 into root 11, root over 11. This is the greatest value. In this way, we are calculating greatest value. Formula is modulus of del f, gradient of f. So first we need to calculate gradient, then taking greatest value as square root of a square plus b square plus c square, where a comma b comma c are the coefficient of I comma j comma k respectively. This value is gives us greatest value. So now one more under greater directional derivative, we have one more topic is also there, that is an important topic. We have to calculate angle between two surfaces. So here is one of the problem, that is find the angle between the surfaces x square plus y square plus z square equals to 9 and z is equals to x square plus y square minus z minus 380 at the point 2 comma minus 1 comma 2. 3 xt, I think so. That is, so that first to be considering phi 1 is x square plus y square plus z square minus 9 equals to 0, one of the surface. And the next one is question is little bit confusion is there. Phi 2 we consider as x square plus y square z minus 3 equal to 0. There is no another term that is equal to 0. So that is x square plus y square minus z minus 3 equal to 0. This is phi 2. So angle between these two, we need to calculate del. Formula is n1 bar dot n2 bar by modulus of n1 bar dot n2 bar, modulus of n2 bar. But n1 bar is nothing but grad phi at the point, at the given point, and n2 bar is also grad phi 2 at the given point we need to calculate. So for that, n1 bar is equals to grad phi 1 at 2 comma minus 2 comma 2. Directly we written as that is 4i bar minus 2j bar plus 2k bar, and n2 bar is equals to del phi 2 at 2 comma minus 1 comma 2. That is also directly after substitution, finding del phi and substituting the point, we got as minus 4i bar minus 2j bar minus k bar. Then angle between these two surfaces, theta we are considering as the angle. So definite that is according to the angle, cos theta is equals to n1 bar dot n2 bar by modulus of n1 bar modulus of n2 bar. So that is n1 bar is 4i bar minus 2j bar plus 4k bar dot 4i bar minus 2j bar minus k bar by square root of first one, modulus of n1 bar is 16 plus 4 plus 16, that is 4 square plus minus 2 square plus 4 square. We want previous slide, okay. This is the one. Question is x square plus y square plus z square equals to 9 and z is equals to that x square plus y square minus z minus 3 equal to 0 ma, that is at the point 2 comma minus 1 comma 2. So for considering phi 1 as x square plus y square plus z square minus 9 equal to 0, and phi 2 is x square plus y square minus z minus 3 equal to 0. For this we are calculating grad phi and grad phi 1 and grad phi 2, that is del phi 1 del phi 2 at the point 2 comma minus 1 comma 2. So directly we got as n1 bar n2 bar. Yeah. In n1 bar value of k should be 4k. Okay. N1 bar is 2 plus 2 plus 2i bar plus 2 value is okay 4k. Yeah ma. that is unit normal. That is normal is nothing but it is an angle between that perpendicular or which angle it is making between that two surfaces. Okay. Here calculation mistake is there, I think so, but the procedure just I'm going to explaining. That is del phi 1 phi 2, we have to given two surfaces, we need to calculate del phi 1 del phi 2 at the given point. We have to calculate that gives us n1 bar and n2 bar. Okay, I will speed up. So cos theta is nothing but n1 bar dot n2 bar by modulus of n1 bar dot n2 bar. So substituting respective values and calculating, we'll get the theta value which is equals to cos inverse of so and so value, because a little bit calculating mistake is there. Procedure is this. You have to remember and write down the statements also. You will get full marks for this. Then we are entering to the second one, divergence of this. We have three topics in this. Four topics are there. One is gradient, second one is divergence, and third one is curl, fourth one is vector identities. All the theorems in that we have. So I'm just give the statements of the theorems, and then we'll discuss question papers also. But if it is the time, otherwise next class we'll discuss the important questions. In the next class, that is tomorrow, after completion of the important questions only, I will start the fifth unit, because this fifth unit we have one more class also, that is on Saturday. Okay, this is divergence. So f bar is any continuously differentiable vector point function. You know idea of vector point function. Vector point function is in the three-dimensional space. P of any function point, if we are considering p of x comma y comma z, we are associating a function scale, we are associating a vector function for that point, that is gives us a vector point function. So here f bar be any continuously differentiable vector point function. Then look at what is the difference between this gradient and divergence. Here in between I bar dot dou f bar by dou x is there. In there, in gradient we don't have any dot product or cross product. Just as usual we are multiplying. That is the difference between divergence and gradient when you are symbolically understanding. So that is I bar dot dou f bar by dou x plus j bar dot dou f bar by dou y plus k bar dot dou f bar by dou z is called the divergence of f bar, and is written as div f bar, div f bar. That is symbolical representation is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of dot into f bar. Only if it is dot is not there, only scalar function is there, that is comes under divergence. If it is dot is there and vector point function is there, that is comes under divergence. There is operatorly represent del dot is there, del dot f bar, divergence of f bar is equals to del dot f bar. Here compulsory f bar is this is for vector point function. But after multiplication you will get a scalar point function ma. This is a scale, last point is there, this is a scalar point function. What is scalar point function? Divergence of f calculating will get a scalar value. Okay, then this after completion of this divergence we have solenoidal vector. This is very important, problems are also there. We have that is divergence of f bar equals to 0, then f bar is said to be solenoidal vector. What is a vector point function f bar is said to be solenoidal if divergence of f bar equals to 0. This point is you have to remember, and problems also we have under this solenoidal. So look at one of the problem. If f bar is given x plus 3y I bar plus y minus 2z j bar plus x plus pz k bar is solenoidal, find p. So we need to calculate divergence. According to the definition, divergence is we what are the this is f bar is given that we considering as f1 I bar plus f2 j bar plus f3 k bar. So for easy evaluation of the divergence formula, that is f1 dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z is gives divergence of f bar. So here it is expanded like this, that is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z dot f1 I bar plus f2 j bar plus f3 k bar. So that is dou f1 by, that is I bar term. We are differentiating partial differentiation with respect to x and adding to the j bar term partial differentiation with respect to y plus k bar term partial differentiation with respect to z. The three we are adding will get the divergence of f bar. So directly in our problems we have like this only. So if you write one more step and expanding and finding also, no problem, but this is the formula, simplest formula of divergence of f bar. So dou f by dou x value already we calculated, we got as 1, that is x plus 3y differentiation partial differentiation with respect to x is 1, y minus 2z partial differentiation is 1 with respect to y, and x plus pz partial differentiation with respect to z is p. So that is becomes 1 plus 1 plus p, that is equals to 2 plus p. But if it is solenoidal means divergence of f bar equals to 0. So p becomes minus 2. So this is one of the problems. Find the divergence of f bar. F bar is equals to gradient of so and so function. So first we need to calculate gradient. So that x square x cube plus y cube plus z cube minus 3x yz we are calculating as phi. We are assuming as letting as phi. Then we going for its gradient. After getting the gradient, we need to calculating its divergence. This gradient phi is we got as I bar 3x square minus 3y z plus j bar 3y square minus 3xz plus k bar 3az square minus 3xy. This I bar coefficient we are taking as f1, j bar coefficient is f2, and k bar coefficient is f3. So directly divergence of f bar becomes dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, which is equals to 6x plus 6y plus 6z, which is equals to 6 of x plus y plus z. So one of the problem like this we have. Then coming to the curl of a vector. So a curl is also defined for the vector point function. Vector point function is defined for divergence and curl. Only scalar point function is defined is that is gradient. So here it is, one definition is like this: f bar be any continuously differentiable vector point function. You want before slide? Okay. Shall I explain, or just you want to show, you want to see the slide? Yeah. Okay. So curl of a vector, here f bar is continuously differentiable vector point function. Then curl of f bar is symbolically represented as curl f bar or del cross f bar. It is defined as f bar is f1 I bar plus f2 j bar plus f3 k bar. Then del cross f bar is equals to determinant of I bar j bar k bar dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. So this determinant evaluation you already know, that is closing of I bar row and column, first row and first column will get the coefficient as dou f3 by dou y minus dou f2 by dou z minus j bar of dou f3 by dou x minus dou f1 by dou z plus k bar of dou f2 by dou x minus dou f1 by dou y. This is how to you are evaluating the determinant. Same way here we are evaluating, but the I bar, J bar, K bar coefficients are also there. So instead of writing minus J bar, you can try the dou F1 by dou Z minus dou F3 by dou Z also. It is a correct process instead of writing minus. So in this, under this curl, we have one more definition is there, that is irrotational vector. So a vector f bar is said to be irrotational if curl f bar equals to 0 bar. If solenoidal means divergence of f bar equals to 0. Irrotational means curl f bar equals to 0. So if f bar is irrotational, this node point is very important. This under this node point will get a damn sure long answer. Okay, that is if f bar is irrotational, there will always exist a scalar point function phi of x comma y comma z such that f bar equals to grad phi. This phi is called scalar potential of f bar. This is one of the important note. This is if it is f bar is irrotational, compulsory there exists a phi of x comma y comma z is a scalar function such that it is satisfying the condition that f bar is equals to grad phi. So this phi is called scalar potential of f bar. This is important for your long answer. We have problems under this also. Curl under we have damn sure question of this potential, scalar potential problem. Now you are able to understand what is the difference between del dot, del cross. This is one of the problem under curl f bar. If f bar is equals to xy square, function is given, we are calculating curl it is. So curl f bar is equals to modulus of I bar, J bar, K bar, dou by dou x, dou by dou y, dou by dou z, and coefficient of phi bar of the function f bar vector function xy square 2x square yz minus 3yz square expanding as determinant form will get as a scale function that is I bar minus 3x z square minus 2xy minus j bar calculating, and at that point if you are substituting we'll get a vector that is minus I bar minus 2j bar. Curl is determinant formula, same we have to apply. This is a position vector. We need in the space r power n into r bar is irrotational. We need to prove. R bar we know that xi bar plus yj bar plus zk bar. R square is x square plus y square plus z square. Partial derivatives with respect to xyz will get as dou r by dou x is x by r, dou r by dou y is equals to y by r, dou r by dou z is equals to z by r. Now we calculating r power n into r bar, which is equals to r power n into xi bar plus yj bar plus z k bar. Its curl we are calculating because it is we need to show that it's irrotational. So curl r power n into r bar, which is equals to 0, we need to show as 0. So expanding in the determinant form and writing in the summation notation, because expanding this totally will get the confusion. So that is summation notation, summation I bar zn r power n minus 1 dou r by dou x minus yn r power n minus 1 dou r by dou z. Yeah, previous slide. Anyway, I'm giving slides now. Oh, time is up now, that is what I have. Is it okay? Just 2 minutes are there. So with this problem we are closing today. So tomorrow we'll going for scalar potential problems are very important. We'll discuss that problems and vector identities. Only just I'm giving the theorem headings, theorem statements. Then we'll go for discussing of important questions tomorrow. So this is expanding form and substituting y by x dou r by dou y as y by r. I can't do in 55 minutes, ma. That is what I am explaining speedily. Try to understand. Okay, 3. Otherwise, I'll send it to your important questions to your mail also. Don't worry. Okay, expanding form. This is will get as 0. Then it is called as irrotational. This is very important. Next problem is scalar potential, but I am not going to explain because is a time up. So next class we'll discuss compulsory what is how to calculate. Mid exam says 2.5 units, last 2.5 units, ma. Syllabus for the mid examination is last 2.5 units. That is what we started 4th unit first. Okay, because you able to ready for your mid exam also. This is going to be held on this 28th onwards. What the clarity you want? I am not able to understand. Ma'am, we get proofs. Yeah, proofs also. That means proofs means vector identity. You have a theorem. There also proofs are there. That you MCQs for mids. That is I don't have. We prepared. That means you go to the textbook and backside questions are there. Please go through that. You told you need to ready by yourself. Means what is the pattern of mid examination? Mid examination pattern is 25 questions are there, only MCQs. Online examination, that is. Mids pattern, that is 20 questions from fourth unit, 20 that means totally 25 questions, ma. That is 2.5 units. Yeah, this is on online. You have exam on online. Mid examination is online. Yeah, be thorough. That is MCQs prepare. Then it is okay. There's something like this only. This is what is divergence, what is curl in this unit. Tomorrow, if I explain proofs, we don't to complete 5th unit, ma. Just I'll give what are the important proofs are there that I'm going to explain. Okay. Thank you. Thank you very much. Tomorrow we'll discuss continuation. Thank you, ma. So how to stop? I'm not able to get in that one. That is what I'm. Sure, I will send the PPT. Directly save కదా సార్ ఎండ్ చేయాలా ఓకే ఎండ్ చేసేస్తున్నా ఎండ్ మీటింగ్ ఫర్ ఆల్ అని వస్తుంది అది సేవ్ అవుతుందా